Is one for today. What last time that some Kaggle teams make their reports? Or I think. John?
No? You prepared, so maybe not.
Okay, so first one, then you also ready, yeah? Other things? Do you need presenter?
You have a question? I don't know.
Yeah.
Let's start. Okay, so I'm going to talk to you about the competition, the Kaggle competition me and my group chose. My group is composed by Anastasia, Andrei Marinov, Peter, and myself. The name of the competition is called 2018 Data Science Ball, and it's presented or like powered by or organized by companies Booz, Allen, Hamilton, and the Kaggle site. So we're going to talk to you or try to explain how the competition works, what are the rules, and what we expect to achieve being part of this competition. So the lemma of the competition is spot nuclei, spot cures. This 2018 data science goal offers an ambitious mission that is create an algorithm to automate nucleus detection in cells. By automating this task, we could help unlock cures much more faster from extremely rare diseases to simple cases as common colds. By participating, the teams will work to automate the process of identifying nuclei, which will allow for more efficient drug testing, even shortening the 10-year period it takes to build or to research for a new drug to come out to the market. So this is first we're going to show you a little video that explains a little bit more clear what is the competition about. Audio works?
I think that's the problem is it's separated grouping itself. So we have to, if you want to use the sound, we should disable the mic.
So this is like a small summary of what they just said in the video. How are the evaluation? What is the evaluation format and the score metrics for this competition? The competition is evaluated on the mean average precision at different intersection over union thresholds. These union over intersection thresholds are calculated by this formula. A intersected with B divided by A united by B. That's the intersection over union threshold. So the metric sweeps over a range of these IOU thresholds at each point, calculating an average precision value. The threshold value ranges from 0.5 to 0.95 with step sizes of 0.05. At each threshold value, a precision value is calculated by the number of true positives, false negatives, or false positives resulting from comparing predicted objects. This is the precision formula we've seen in the machine learning courses. Then, for one single image, the average precision is calculated by the mean of the precisions at each of these IOU threshold. And at the end, like for a general score, each of the mean scores achieved by each picture, it will be a global mean that will give us the final score and placement for the competition. The rules and prizes. The competition timeline is started on January 16th of this year. It ends in April 19th. April 9th of this year. But April 11 is going to be a second stage data release. So we have to be prepared for those 2 dates, 9th and 11th of April. And the complete competition will be ended 16th of April. Prizes for the first place, there's a $50,000 prize plus a top-of-the-art system provided by NVIDIA. Second place is $25,000, third place $12,000, fourth place $8,000, and fifth place $5,000. We did some exploratory data analysis on what we're going to start doing on the competition. We found with the data that we obtained from the competition, there are 670 training images and 65 test images. This means that less than 10% corresponds to the training set. Here we have a classification because each images are different sizes. So this is a categorization of the different sizes available. The pink color is the test photos and the yellowish is the training. We observed that 7 of these picture dimensions are not, in total there are 16 different picture dimensions, and 7 of these sizes are not available on the trained data set. So we have to be careful with that when training on the training the algorithm. These are some examples of the images that are provided by the competition. Random choices of all the images available. As you can see, they are categorized with different sizes according to the pixel size of each image. And I'm going to briefly discuss how we are supposed to do the nuclear identification process. In the data we obtained, we got the upper image is the image itself of the cells, and accompanying each image, we have a folder inside with that image, what they are called masks. This lower image is a mask that what it does, it has to be like put on top of the original image, and it will narrow down where we have to look for the nuclei. So the process will consist of identifying the contours of the mask, apply the mask on top of the image, so only this piece of information will be available to see. And then when start checking the contours, and for each contour extract the metadata from the mask, extract the nuclei, and make it to get flip horizontal rectangle, just to have an uniform form after we have placed the mask on top of the images. For each image, there are several masks, so we have to do this sort of task in a repetitive form and train how to recognize these spots that are left in the mask. So this is like a more descriptive process. Here, for 3 different images. Here we have the original image. First process is get a bit of color enhancement, then applying the mask. Here they are applying some filters for color. Then this is the same piece here, front, and then it's turned, so they all have a consistent size or shape or orientation. So this is the process that we will have to do with each of the images to train our data and do the same with the test data. So brief description. Any questions?
If this turn back on nuclear recognition side.
It's all about the recognition.
The top of this is the identification. So, hint that I didn't get is this is the spot.
Yeah.
Down picture of mask.
For example, we have 670 images of this, and each of these images comes with several masks that are
How to define masks?
Very good
they are
question.
provided. So the masks are provided with our data. We have to put like as a top layer of the original image, and we are only going to analyze the space available by what the mask shows to analyze. And
So the mask will be given during the educational process.
Yes,
It's
for the
given
training.
on the train set.
For the training.
Yeah, it's some kind of labels.
Like
for train set.
you're using the algorithm like neural network, yes?
Not yet.
Oh, yeah, like algorithm.
Our first approach is not going to be with neural networks. No.
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 So
First approach-
you don't know the algorithm. You're just saying that.
That's the
it-
question. I don't understand. That's the question for us to make these masks. These masks are kind of answers for this.
Mask is like, for example, if a biologist take the cells and do it manually, that like they build like a mask, so that's to help us train the algorithms how to start recognizing it automatically.
Yes, so the main point is, and the input of the training model will be the photographs like that, and you have to, like, for the output, give the kind of black pictures with white colored on the top of each cell contained on the picture. So we can like see this. This is more like identification pixel by pixel. So we have to say whether this pixel relates to the nuclei or it's not. And this is the answer model will give for the entire picture provided in the model.
What the mask does is to narrow it for the complete image, just a little space we have to look into it. Other questions?
No questions, okay, thank you. Один стул там есть. Он такой так можно забрать.
Не действительно стоят.
So, our Kaggle challenge is Google Landmark Recognition Challenge. It's directly related to another Google challenge called Landmark Retrieval Challenge. They are slightly different. Our one is to we need to recognize the landmark. In Russian, it's test on the photo on the test data set. If there is any so there are not many challenges about. The main problem usually with data set. And you might heard about ImageNet large-scale visual recognition challenge, but it is slightly different because it suggests about 1,000 objects on the dataset, and our challenge is about 15,000 landmarks. So on the dataset, there might be not many pictures with each landmark, each individual landmark. So each picture in the dataset may contain no landmarks or several, 1, 2, and so on. Because of rights issues, Kaggle doesn't provide the data itself, but it provides links to the images. So there is also a problem that some part of the dataset will be corrupt. They might not be the image on the server. So first of all, we will have to begin to clean it up. So the actual CSV file is something like this. And it's about 1,200,000 of lines. The original dataset was built on the first two. Actually, it was built like this. First, we're taking about 20 million of GPS tagged images, also images from the traveling tourist websites with labels on them. There was then authors created a model with unsupervised modeling. So, and then the main part, the dataset itself, mostly built on the photo sharing websites photos. Like people photo themselves with the landmarks and post it on the internet. Using these photos and this model, model decides that there is or there isn't a landmark on it, and they ask authors of the photos to confirm or say that the model was wrong. So this is, I think, about it. Yeah, I think.
Okay. I'm going to continue with how we need to prepare the images. And preparing images, there are problems you are going to encounter when you prepare images. First, the first problem you are going to encounter is most of the images will have different sizes. And second, most of the images can have a different quality. And most images can have some lines. And the very well human which hides some part of the landmark. And most images will transform into the how to transform the images into matrix. And these are the approaches or the solution to such problems which we will encounter when we are preparing images. So the first solution is how we will be able to plot how be able to plot the distribution of image sizes. And the second is how we will be able to split the dataset images to classes based on our plot. And we will set a percentage of a particular percentage that if that particular image that don't fall into that piece, and then you drop it out from the data set. And the third is you will scale all our images. And most images have different qualities. With the qualities, we will then apply filter matrix by enhancing the clarity of the image. So we just apply a filter method which happens to have a good image or a good image. And then we also consider how we are yet to consider how we're able to integrate some noises, because there are some noises in the images and we don't know yet they are going to use to integrate the noises, so we are yet to learn and then find a solution to that particular task. Then we transform the image to a matrix. Here we decide to transform our images into a matrix where such matrices will group into colors. That the red color and then the green color and the blue color. So the value of each color will identify each pixel in each matrices.
Probably a good quick tour to the methods that we are going to apply to solve the problem. Then the images are already in the array of matrices. We're going to use, pre-built convolutional neural networks, which has put their good qualities on the, for example, MichNet competition like AlexNet or GoogleNet convolutional neural network. And I will talk about some theory on the convolutional neural networks. It's not a tree, but I will just quick discuss it. So the convolutional neural network, different from the usual neural network, having like convolutional layers, which are in the network to smother the area of the coordinates. So like you can see, there's part of the images that all the filters. We will apply filter to try to find this or any other filter in the area of the picture. For example, we have like this filter, like this part of the image, and we are trying to find this part of the image in our original image. For example, you can see it here. We will apply the filter, and every applying procedure, every digit in the matrices that you can see on the first step, then we apply convolutional step. We will represent will be as high as this filter satisfied. Each our part of picture satisfy these filters. So they're trying to apply filters, and then the picture passes through convolutional layer. The output of the first layer will become the input value of the second layer, and so on, so on, so on. We will try to use some difficult parts of the image. We'll try to find it, and the last layer of this convolutional neural network will be full connected layer, which will represent the quality of every class that we have. So as big the output of the full connected layer is, as big will be probability that our image is from the some class. So this is full picture, as you can see in the picture, and this is all from our team. Thank you for your attention.
So you described only one method, as I understood?
Yes, we described only one method. Because it was our first guess, what should we use to solve this task? And for now, we don't have any results because we didn't apply the algorithm. Just our guess what will be for us.
So we also consider the capsule network. This network is better than convolutional network, but we don't know how it works. That's not. It's our first approach. First idea.
And if you implement it and see that it's not good enough, will you look for other methods?
Don't hear the question, sorry.
Will you look for another methods or no?
Our first step will be to use like simple methods, like I don't know, random forest or gradient boosting classifier or something like this, and see what kind of quality we will have. But we suppose that we will have low level of the quality, so we will think through this and tell that we are going to use convolutional level method. Yes.
Did you guys look for the new Google approach called Google Net?
Yeah.
Yes.
They heard AlexNet and Google Net.
Google Net.
Yeah. Google Net, yes.
This is for the detection. So this. Now, I mean, you can detect and then like.
Yes.
So this is like new release, I guess. I'm personally looking for it now. Maybe you can try to see, because for now, as I know, this is the best approach ever.
Yeah.
Wait, what's that? It's Peter. What's Google Net?
Google Net. This is the framework for detecting objects on images.
Oh, I mean, it's a library with pre-trained models,
Like
right?
based on the convolutional network.
Yeah.
Yes. It's like
So it's
300 layers of convolutional network.
I don't think it's gonna work. Ну, предыдущая на каких-то базовых мышках, клавиатуре.
So other questions? No. Thank you again.
Thank you.
Оставляю чуть биры, которые уже пришли хорошо, и разбивать. Потом смысл.
Hi everyone. The name of our team is Team A, and now we are working on token data Kaggle project. Our team consists of 2 people, me and Alexander. So now description of the problem. As you know, some companies have online advertisements, and they suffer from fraudulent leaks because there are a lot of bots, and about 90% of all clicks are fraudulent. And our goal is to predict what clicks are fraudulent and what clicks are not fraudulent. How about data description? So, our training set is 7.5 gigabytes. Total number of instances is about 180 millions. Number of features is 7. So here we can see that our training set is very unbalanced. Class 1 we have only 0.5 25%, and plus 0 is 99%. And test set is almost 1 to 5. So we have 7 features. All features except data are encoded. And first feature is IP address, second app, ID of application, ID of device, ID of operational system, ID of publisher, click time, attributed time, this feature only in training site, and label is attribute. So as not users clicked and then downloaded the application, is attributed shows 0 and attribute time is none. This table shows how many different values we have in each feature and the range of each value. For example, in IP address we can see the 300,000 different values. And in total we have about 200 million objects in training set. It says us that some IP addresses mix the advertisement more than one time. And also you can see another values in this table. We have some problems, some features encoded, and we can't extract information from them. But some features are not encoded, such as data. And for example, we can split data in daily, week, hour, and minute, seconds. Also, we can unite some features and extract information from already existing. For example, how many this IP address was leaking this advertisement. Second problem is that classes in our training set very unbalanced, and for some algorithms this is also a problem. I'm going to implement for algorithms logistic regression, random forest, neural network, and gradient. Two algorithms will implement standard, two algorithms will implement this all.
Questions. You are talking about random forest. Random forest is a kind of cheap and fast models and ensemble. Ensemble, yeah. So, what kind of cheap easy models will also during random forest?
We didn't choose any, but I think it will be some kind of logistic regression.
So, okay. So you understand that this integration will not work in your case, because round with 7 features.
Firstly, we are going to implement logistic regression, and then we can say, is it enough or not?
So your first approach is to first implement logistic regression and then use random forest of logistic regressions. Right?
No, just on these two, maybe like new classifier. So get about logistic regression.
No,
Right?
Yes. But random forest consists of some algorithms and some cost function.
Yes.
В общем случае random forest can use different algorithms.
Yeah. So you just said random forest. It's kind of we're going to use model or some kind of.
Any questions?
Other projects?
No more projects.
No more projects.
We will do it on the next on the next academic seminar.
You will present next time.
Yes.
Okay.
That's all for the day. Thank you.
Thank you.
Girls, Alexandra, Nastya, Madina.